Don't see yourselves as just sugar producers. Your factories are platforms for the next industrial revolution.
Welcome to the second episode of Stable Connections, the KEBO podcast about specialty chemicals, processes, and the people behind them. In our anniversary year of 2026, which marks 100 years of KEBO, we are looking ahead to the long-term developments that are changing our industry. This episode focuses on one key question: how is industrial biotechnology transforming sugar from a traditional raw material into a strategic carbon source for the chemical industry? In this episode, titled Advances Industrial Biotechnology Making Sugar a Super-Feedstock for Substituting Petrochemicals, we explore the technological, economic, and industrial potential of this development, as well as the challenges that still need to be overcome. To this end, I welcome a guest who has been following the international sugar industry for decades and has been reporting on its transformation. Arvind Chudasama, member of the editorial staff of the trade magazine Sugar Industry. Welcome, Arvind. Great to have you here.
Thank you.
Arvind, would you like to briefly introduce yourself to our listeners and explain how you became involved in the sugar industry?
Certainly. So, following my master's degree in tropical agronomy at the University of Queensland in Australia, I moved into agricultural development. I worked in Nigeria and Eswatini before a quirk of fate directed me to Sheffield University to study information science. I subsequently moved into publishing, working for CAB International, where I got to edit sugar industry abstracts. Then, over 20 years ago, an opportunity came to edit International Sugar Journal. For the past 3 years, I've been working in an editorial capacity at Sugar Industry International, based in Berlin.
Modern biotechnology is turning sugar into a versatile raw material for fuels, chemicals, and plastics, which were previously produced mainly from petroleum. Could you explain the most important reasons why we need to replace petrochemical products in the first place?
Absolutely. The shift isn't just a trend, it's a fundamental necessity driven by three critical factors. First, and most obviously, is the climate crisis. The production of petrochemicals is incredibly carbon intensive. As your listeners may know, the chemical sector is the largest industrial users of oil and gas and a significant source of global carbon dioxide emissions. For instance, making just 1 ton of fossil based ethylene releases about 2 tons of carbon dioxide. We simply cannot achieve a net zero future without decarbonizing the materials we use every day. Second, it's about security and geopolitics. The vast majority of plastics and chemicals are manufactured in a handful of regions, creating fragile, long supply chains. The events of recent years have shown us how quickly this change can be disrupted. Producing chemicals locally from renewable feedstocks like sugar offers a more resilient and secure domestic supply. And third, there's the issue of toxicity. Many petrochemical processes rely on hazardous substances. A great example comes from the University of Liège, where researchers are developing isocyanate free polyurethane foams. Traditionally, polyurethane production uses isocyanates, which adversely impact respiration. This new bio-based methods creates a high performance foams for things like car seats and insulation, but without the toxic baggage. So we are moving towards a chemical industry that is not only lower in carbon, but also cleaner and safer.
Yeah, so we see very important issues that there must be changes in the future. The industry now refers to sugar as a super feedstock. What is your view on this? What can sugar do that other bio-based raw materials cannot?
It's a bold term, but I think it's justified when you look at the full picture. Sugar's superpower lies in a unique combination of three things: its existing infrastructure, its molecular efficiency, and its versatility. So let me go through these three things. First, infrastructure. The sugar industry isn't new. Sugar has been produced on an industrial scale for over 200 years. This logistical backbone is already in place, which is a massive advantage over starting from scratch with a brand new exotic feedstock. Second, molecular efficiency. Look at what's happening in the industry. The South Korean company Hyosung is the world's largest spandex maker. They're investing billions of dollars to build a plant in Vietnam that uses Genomatica's technology to ferment plant sugars into bio-BDO, the key ingredient of spandex. Genomatica claims it generates 90% fewer greenhouse gases than the conventional fossil-based process. Third, versatility. Sugar isn't just for ethanol anymore. We are seeing it used to produce a mind-boggling array of products. Companies like Solugen are using corn sugar to make organic acids for concrete and cleaning products. Nirani Sugars in India is building polylactic acid bioplastics plant. Balarampur Chini Mills in India is doing the same.
So there is much more than bioethanol where everybody is thinking about when it comes to sugar fermentation. So you named a lot of very good examples. Yeah, also sustainability is an issue. You mentioned it before. How does the CO2 and cost balance compare to that of traditional petrochemicals, both now and in the future?
So this is $1 million question, and the answer is increasingly positive for bio-based products. On the carbon dioxide balance, the difference is stark. Petrochemicals take carbon that was locked underground and release it in the atmosphere. Bio-based products, on the other hand, work with the planet's natural carbon cycle. The carbon in the sugar was pulled from the air by the plant as it grew. The numbers are compelling. The core BDO plant, which is a joint venture between Cargill and Helm, have just opened a plant in Iowa. And its carbon footprint is about 80 to 90% lower than fossil-based BDO. Solugen's new Minnesota facility is projected to cut 18,000 metric tons of carbon dioxide annually. And it's not just about making new stuff, it's about using waste. Researchers from the University of Amsterdam and Avantium are partnering to recycle polycotton textile waste into glucose for new bioplastics. Now, on the sort of cost balance, we are seeing a shift to green incentive. This happens for two reasons. First, you are decoupling the volatile price of oil. A sugar mill in Brazil isn't subject to OPEX production cuts. This provides a long-term price stability. And second, by operating a biorefinery, you are not just making one product. A sugar factory can produce food-grade sugar, ethanol for fuel, and now biochemicals for high-value markets. So you're diversifying revenue streams. The work from the University of Zagreb, which developed an integrated process to make both ethanol and the high-value sugar alcohol erythritol from sugar beet, is a perfect model of this more value from the same crop approach. This is what makes economics work.
Yeah, very big potential, and there is a lot of going on when it comes to research and development. One question is, can such processes really be scaled up on a large scale?
Yeah, the question of scale is the ultimate test, and we are seeing it happen right now. The industry is moving out of the lab and into the real world. The proof is in the plants being built. We already talked about the coal plant in Iowa with its 66,000 ton capacity. NatureWorks is building a 75,000 ton PLA plant, that is polylactic acid plant in Thailand. In Abu Dhabi, they are breaking ground on the Falcon project, which aims to be the world's largest PLA plant with a staggering 160,000 ton capacity. Biotech startup iMicrobes demonstrated scalability by increasing its bio-based acrylic acid fermenter size from 2 liters to 1,500 liters. That is a 750-fold increase. So these are not just pilot plants, these are commercial scale industrial facilities. We are also seeing scale up in partnerships and investment. The $1 billion investment by Hyosung in Vietnam for bio-BDO shows the confidence major industrial players. This isn't just joint venture capital anymore, it's government backed strategic investment.
So, and in your opinion, what are the current game changers that make sugar an interesting raw material for the chemical industry?
In terms of application, the transition is already underway. You might not see it on the shelf, but you are probably already interacting with these products. So, in plastics, the most visible application will be in food packaging. That's likely PLA, which can now be made from sugarcane or cornstarch, as in the new plants in India and Thailand. Think about spandex in your active wear. The new bio-based spandex from Hyosung is indistinguishable from the conventional version, but has a fraction of the carbon footprint. In solvents, the application is a drop-in replacement. Companies like Crop Energies in Europe are building plants to make ethyl acetate a common solvent used in inks, coatings, and adhesives, but from bio-based ethanol. It's chemically identical, so the paint factory doesn't need to change a thing in its process, but the final product is far more sustainable. The French company Global Bioenergies is targeting the cosmetics market with the bio-based isobutene derivatives for makeup and skincare under the Isonaturin brand. So in additives and specialty chemicals, the applications are incredibly diverse. The lignin-based hair conditioner from Stockholm is a fantastic example. We also have the work from University of Leeds creating super lubricants from potato protein.
So that means also from an European perspective, we are in a good position compared to countries like Brazil or Thailand, which are famous for cane sugar applications.
Yeah, I mean, traditional factories are not just sort of to be suppliers of sugar. They are poised to sort of become, the heart of a new bioeconomy, the biorefineries of the future. They are the perfect hosts of this industrial revolution. Think of them as industrial platforms with immense built-in advantages. They have the feedstocks on site and they have the infrastructure, steam power, waste treatment, logistics, and skilled workforce. So they already process a pure fermentable sugar. The leap from producing sugar and ethanol to producing bio-based chemicals is a logical and powerful next step. So we're already seeing this happen. Sud Sugar has agreed to supply sugar with molasses and pulp to the French startup Affurance zero waste biorefinery producing organic acids. Another sort of prominent examples mentioned earlier is Balrampur chini mills in India. They are a major sugar producers now. They are building India's first commercial scale PLA bioplastics plant right next door to one of those existing sugar mills. They are literally integrating the new bioeconomy with the old.
Yeah, that sounds very promising. But what obstacles do you currently foresee in terms of technology, regulation, and market ramp up?
Well, you're right. It's a very promising future, but it's not without its significant hurdles. Not a switch. There are real obstacles to overcome. On the technology side, the biggest challenge is still titers, rates, and yields. The jargon for efficiency. Can we get the microbe to produce enough of the molecule fast enough and from every gram of sugar to be cost competitive? For some molecules, yes. For others, we are not there yet. And even when the biology works, the downstream processing, separating the product from dilute fermentation broth, can be incredibly energy intensive and costly. A recent paper from TU Delft University highlighted the exact problem for recovering isopropanol and acetone, and they developed a new distillation methods to solve it. So the technology is advancing, but it's a continuous battle for efficiency. Regulation is another huge challenge, and it cuts both ways. So, on one hand, we need smart regulations that create a market for sustainable products. The EU's push for a circular economy is a good example. On the other hand, we have a chicken and egg problem with new materials. A new bio based plastic, even if it's superior, has to go through a long and costly approval process for food contact applications. And there's a lack of clear, harmonized policy framework. As Rob Bickers from Cargill pointed out in an interview, without clear rules, it's hard for companies to make the multi-billion euro investments needed to build these industries. And finally, ramping up. This is the valley of death for many innovations. You have a great lab scale process, you even have a successful pilot plant, but process engineering changes markedly during scaling up to a commercial facility. Many startups have failed during this process.
So that means we are on a good way, but there is a lot to do. Maybe when we look into the future, 10 to 15 years ahead, what role will sugar play in the chemical sector? A niche, or will it be the new standard?
I'm convinced that in 10 to 15 years, sugar will be well on its way to becoming a new standard, a foundational feedstock for a significant portion of the chemical industry. The question won't be if a chemical is bio based, but which bio based feedstock was used. So we are at an inflection point. The technology is proven, the investments are being made at the $1 billion scale, and the demand is being pulled by consumers, brands, and regulators. The conversation is shifting from is this possible to how do we scale the fastest and how do we make it most cost effective. I see a future where a chemical complex looks very different. Next to a traditional naphtha cracker, you will have a biorefinery. They'll be integrated. The biorefinery will take locally grown or waste derived sugars and convert them into basic building blocks, the BDO, the lactic acid, the ethylene glycol, that then feed into the same downstream polymer and chemical plants. This isn't about replacing one with the other overnight. It's about creating a hybrid, more resilient system. We will see spectrum of products from high volume, relatively low cost plastics for packaging to ultra high value complex molecules for medicine, all derived from the same flexible starting material, sugar. It will become a core pillar of a truly circular and sustainable economy.
Finally, what is your most important message to the decision makers in the chemical and food industries, especially in sugar processing companies?
My message is simple but urgent. The future is bio based, and the time to act is now. You have the key to that future in your hands. To my colleagues in the sugar industry, I say, look at what Balrampur Chini Mills is doing. Look at what Sud Sugar is exploring through partnerships. Don't see yourselves as just sugar producers. See yourself as carbon farmers and biorefinery operators. Your factories are platforms for the next industrial revolution. Start small, partner with tech providers, and invest in R&D. Your most valuable product in 2035 may not be the sugar on the kitchen table, but the sustainable polymer in a car bumper or the bio based chemical in a life saving medicine. And to the chemical food industries, I say, embrace this transition. It is a source of immense innovation and competitive advantage. The tools of synthetic biology are giving us the power to design materials with precision and performance that rivals and can even surpass petrochemicals. Partner with the sugar producers, invest in the startups, and help build the supply chains of the future. The challenges of climate change and resource security demand a new approach. The technology is ready. The feedstock is growing in fields right now. What is needed is a leap of faith and enterprise.
Arvind, thank you very much for the interview and your assessment of the future of sugar as a super feedstock alongside its original role as a foodstuff.
Thank you.
That was the second episode of Stable Connections, the KEBO Podcast, today focusing on the topic of sugar as a super feedstock for substituting petrochemicals. Our next episode of Stable Connection explores a different kind of connection, not between raw materials and chemistry, but between marketing, technology, and digital system. We will examine how CRM structures, data analytics, and automation tools are reshaping B2B communication and influencing strategic decision-making.